Okay, welcome to lesson 4.5. Today we're going to talk about something called interval notation. We've been doing inequalities for the last 4 lessons, and we're going to learn how to write inequalities in a different way using interval notation. So your aim today is that I can use interval notation when solving, evaluating, or discussing inequalities. We will often want to talk about continuous segments of the real number line. We've already done work with this in the last lesson using what's known as inequality or set builder notation. That's that notation where it's like x is less than 4, less than 0. That's set builder notation. Today we'll see a very simple way of showing this kind of notation. Okay, instead of having to use the less than or greater than signs. So let's take a look at exercise 1. I'm just rewriting that 4 there. Exercise 1 says, for each of the following, graph the portion of the number line described by the inequality, and then write the equivalent using interval notation. So first let's graph the inequality. X is greater than or equal to negative 3, and x is less than or equal to positive 5. So I'm going to put the negative 3 as a closed circle, and a 5 as a closed circle, and we're going to connect them. Now, interval notation is really awesome, because really all you need for interval notation is a starting point and an end point. So your starting point here is negative 3, and your ending point here is 5. So we use brackets to show that x is between negative 3 and 5. Okay, we used hard brackets to show when something is closed. Or if it's got the equal to at the bottom, to show that it's included. The next example uses something different. The next example says x is between negative 6 and 4, but the only difference is these are open circles. So I have an open circle on negative 6, and an open circle on positive 4. Still combine them when I graph, but this time, instead of using a bracket, I'm going to use a parentheses, because parentheses shows that it's not including that negative 6 and 4. So at the very top of the paper, notice I've written your little key, that parentheses are meant for open numbers, where you've got like a less than or a greater than, and brackets are meant for closed values. Okay. How about you try letter C on your own? You can pause, try it on your own. Okay, so for C, I've got negative 4, and x is between negative 4 and 8. Now notice that I've got an open circle on the negative 4 and a closed circle on the positive 8. So the cool thing about interval notation is that I can use that open bracket for the negative 4, but I have to use a square bracket for the 8. So your answer looks like this, with an open bracket and a closed bracket. Okay, that's totally okay. Notice these are not the same as coordinates. I know that we think parentheses and you think coordinates, but this is interval notation, it's different. Okay. Letter D is also a little different because we have to use something called infinity here. So D says that x is greater than or equal to 4, and that's it. So when I go to my graph, I'm going to put a closed circle on 4 and then draw an arrow. And it goes on forever and ever, right? Oh, I forgot to go back here and make this line. Sorry, my bad. So on letter D, this is going to go on forever and ever and ever. So we have our starting value at this 4 here, and I have a closed bracket. But since this goes on forever, we call that infinity. Okay? We use parentheses because infinity never stops. A closed bracket indicates something stopped. That's the last number it can be, but infinity goes on forever, so we use an open bracket. So also, if we go back up to the top of the page, oops, I'm accidentally moving this. If we go back up and write ourselves another little note here at the very top, saying that infinity means we're going on positive forever. On the other hand, if we have something that goes on to the left forever, that's negative infinity. Okay, this goes negative forever. All right, so let's take a look at E and F to explore this a little bit more. E says x is less than 5. So it's an open circle on 5. And I'm going to the left because it's less than. Now this is going on forever to the left, so that's negative infinity. So open parentheses, negative infinity, comma, 4, and then I have a closed parentheses here because the 4 is an open circle. Letter F, last one. Negative 4 is less than x. Now I always want to rewrite it so my variable's on the left side of the inequality, so I'm just going to flip the whole inequality around. So I put the x on the other side, I flip my inequality symbol to a greater than sign, and then I put the negative 4 at the end. Now I can graph this. X is greater than negative 4. I have an open circle, and it's going to the right. So my lowest value is negative 4 to the left, and my highest value is in positive infinity. Okay, so you're basically thinking of your starting value. Oh, my pen's doing that thing again. You're thinking of your starting. Sorry guys, my pen is. What is your start value and what is your end value? Okay, that's what you're thinking about, your start value and your end value. You're also thinking about, do I want a closed bracket or do I want an open bracket? Okay, let's take a look at some more exercises. One of the great advantages of interval notation is that we just essentially need to know a starting value and an ending value, and then whether or not that those two values are included, whether we need the open bracket or the parentheses. So which of the following represents the equivalent interval to negative 4, less than or equal to x, and less than 4? Well, negative 12, that's your start, and positive 4, that's your ending value. And now you have to think about, is the 12 included? Yes, because it's got that equals to. So this is like saying negative 12. Is the 4 included? Nope, because it doesn't have the equals to underneath it, so that would just be 4 parentheses. Your answer choice is number 3. Easy. And again, if you're confused or lost, mark this notes on your page and then come to class or email me with your questions, right? Exercise 3. Eventually we'll use interval notation to express solution sets to inequalities as well as to describe sets of interest to us. So exercise 3 is talking about solutions, right? The previous problems we just were given numbers and saying this is the answer, here are all the graphs, here are all the answers. But what happens when we have a problem like in exercise 3 where we have to solve this first? So that's exactly what we're going to do. We're going to solve this first. This is a positive 12. I want to get rid of it onto the other side. So they cancel out and I get negative 4x is greater than negative 12. Divide both sides by negative 4. And remember, when I divide by a negative, what do I have to do to that inequality sign? I have to flip it so it becomes a less than sign. So I get x is less than 3. Do not forget to flip when you divide by negative or multiply by negative. I'm going to write it on here to remind you. Don't forget to flip. Okay? So now that I have x is less than 3, now I'm going to graph it. I have an open circle on 3 pointing to the left. And in interval notation, this is going to go on to negative infinity forever. So it's negative infinity. And then the highest value is that 3, but it's not included, so I have a parentheses. Okay? All right, exercise 4. Exercise 4 is where we're going to talk about compound inequalities. So intervals express information about particular values of a variable. We can look at the same types of problems from the last lesson, compound inequalities, when intervals combine in various ways. Exercise 4 says two inequalities have solution sets given in interval notation below. So the first inequality says the solution is negative 3, x is greater than or equal to negative 3, but less than 2. And inequality number 2 says that x is greater than 0, but less than 4. Part A says write an interval that represents all values that are solutions to both inequalities. So we're looking for that and relationship where they work with both. And we're going to draw number lines to help you think about this. So let's draw a number line. Okay, here's my number line. And 2, 3, 4, 0, 1, 2, 3, 4. I'm going to label this. Oops. So I'm going to draw a number line to help see this solution better. So there's my number line. And I'm going to make interval number 1 show up in green. So interval number 1 is green. So interval. I'm at inequality. Negative 3 to 2. So I have a closed circle on negative 3 and an open circle on 2. And they're connected. So that's my first inequality, and I'm going to graph the same inequality on that same number line here to try and see where they overlap. I have an open circle on 0 and an open circle on 4. And now I'm going to look, where do these two intervals overlap? They overlap here. Right there is where the two things are together, where the word and comes into play. Okay, so when I write my new interval is going to be, well, what's my lowest value? That's my lowest, and this is my highest. So it's like my start and my end. So when I write interval notation, I'm going to have an open circle at 0, because remember it's not included on the purple inequality, and an open circle at 2, because the green one is open. And this is my solution to both of them, where they overlap. So you're thinking about overlap when you're thinking about and. Now letter B has us doing the same thing, but instead of thinking about and, we're thinking about or. So we're going to do the same thing we did last time. I'm going to make it separate here, where we're going to draw our number line and compare. So here's my number line. Okay. And I have the same thing. 1, 2, 3, 4, 0, 1, 2, 3, 4. So I'm making my number line. And I'm going to do the green one again. So I make my closed circle on -3 and my open circle on +2 and connect them. And do the purple one, where I have my open circle on 0 and an open circle on 4. Remember, I'm just graphing these two inequalities at the top here. Now I'm thinking about or. Now, or is, it can be, it's either this inequality or that inequality, so really it can be any of it. So when you think about the phrasing or, you're thinking about or not just being overlap, but being the whole thing. So or is like saying the whole thing. My pen is being crazy. So if I want to look at the whole thing, that means that I'm looking all the way from here, where they overlap, and beyond. So there's the whole thing. So how do I write that as an inequality with using interval notation? Well, my lowest value is this -3, and my highest is that 4. So I have -3 with a square bracket because it's included, and a +4 with a open parentheses because it's not included. Okay? So two different answers in interval notation for and or. Really important to think about and or when you're reading your problems, paying very close attention to that. Alright? Finally, let's look at this last exercise, the multiple choice problem. At a hydroelectric plant, pump number 1 is on for all times in the interval 0 to 8, and pump number 2 is on for all times in the interval of 4 to 18. Which of the following represents all times when both pumps are on? Now the first thing I'm going to do to try to solve this problem is I'm going to draw a number line like I did for this problem, because this problem really helped me look at the overlap. This problem is saying when both pumps are on, so I know that I'm looking for that overlap. So I'm going to draw a number line like I did for the last one to help me now. My number line's got to go from 0 all the way up to 18, because that's how long my problems are. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18. So my number line goes all the way up to 18. I'm going to label it 0, 1, 2, 3, 4. This is taking time, but this is going to help you visualize the problem a lot better. Instead of just trying to look at those intervals and try and guess what they're talking about, this will let us see the overlap. So I'm going to graph this one first, this 0, 8 one first. It's got a hard bracket on the 0, so I know that 0 is included, so I'm going to make a closed circle. And it's got a parentheses on 8, so I know that's an open circle. So there's my graph for the first one. Now I'm going to graph the second pump, which is on this interval. 4 is a closed bracket, so I have a closed circle on 4 and an open circle on 18. And now I'm going to look, where do these two graphs overlap? I'm going to use my pen and I'm going to color over that. This is where the overlap happens. where they share. So my answer is going to be my lowest value, which is right here. That's my beginning. And this right here, which is my end. So how do I write that interval notation? Well, it's a square bracket because it's circled. It's a closed circle at 4. And then I have an open circle here at 8 where it ends. So it's 4, hard bracket 4, comma 8 parentheses. Now that doesn't show up my answer choices because it wants me to put it into set notation. So I have to take this, and easily enough, I'm going to put the 4, T, and the 8, and now I got to figure out what goes in between them. Well, because 4 has this square bracket, I know that this has to be equal to inequality, and because 8 has the open bracket, that's going to be just the less than symbol. So I've converted from interval into set, and that answer choice matches up with answer choice number 1. Okay. Notation is all about memorizing, so go back through your notes, notice the hints I've given you at the top, and please, please, please ask me or Ms. Vasquez for help when you do your fluency if you need it. Okay? Good luck.